This video is over factoring trinomials. So again, we have our steps to whenever we want to factor. Our first step is we want to factor out the greatest common factor. And then once we factor out the greatest common factor, determine the number of terms and decide which method you want to use. So we want to factor 18y cubed minus 12y squared plus 2y. So first step, always look for a greatest common factor. Hopefully you see here that there's a y in at least each of them. So I know y can be a greatest common factor. But there's a greater value than just y. We have 18, negative 12, and 2. Hopefully maybe you see by now that 2 is also greatest common factor. If you can't see that 2 is the greatest common factor also with the y, then write out the prime factorization and go through that process. So my greatest common factor here is 2y. So what I need to do is I need to factor out that 2y from this polynomial. So I factor out the 2y, which means I divide the 2y into each of these. So 18 divided by 2 is 9. Y cubed divided by y is y squared. I'm going to bring down my minus sign. 12 divided by 2 is 6. Y squared divided by y is y. I bring down my plus sign. 2 divided by 2 is 1. Y divided by y, those cancel. One in the top, one in the bottom, they're gone. So I get 2y times the quantity 9y squared minus 6y plus 1. It's factored, but it is not completely factored. Always check to see if what's left over, in this case the 9y squared minus 6y plus 1, check to see if that is factorable as well. So sometimes you're going to have to factor within the factoring, which is what we're going to have to do in this case. So yes, it's factored. It is not completely factored though. A lot of your homeworks will say factor completely. So if you type this in, yes, you're right, but you're not completely right. So we're only focusing on the stuff inside the parentheses now. I'm only going to be looking at that 9y squared minus 6y plus 1. How many terms are there? Hopefully you identified 3 terms, the 9y squared, the negative 6y, and the 1. So whenever you have 3 terms, again, one method that you can use is AC grouping. If you're comfortable with a different method, as I've mentioned before, feel free to use whatever method you're comfortable with. I'm focusing on AC grouping here. So first thing we need to do is we need to identify the A, B, and C. A is 9, B is negative 6, and C is 1. Again, make sure you pay close attention to your signs. That negative 6 makes a big difference. Then we go through and we multiply A and C. A is 9, C is 1. Ooh. 9 times 1 is 9. Then we list every pair of factors, so every pair of 2 numbers that multiply to 9. So we know 1 and 9 will work out. We also know negative 1, negative 9 work out. Hopefully you realize 9 is not an even number, so it's an odd number, so no even number will divide into that. So I can skip over 2, 4, 6, 8, 10, 12, 14, 16, and so on. So I go to 3. Is 3 divisible by 9? Yes, it is. I have 3 and 3, which also means I have negative 3 and negative 3. And then when I cycle back up to the other side, I'm done. I have 3's repeating, so I've covered them all. If you want to check, you can check 5. 5 hopefully you realize won't divide into 9. Check 7. 7 won't divide into 9. And then 9 divides into 9. You already have that pair listed. All right, so once I have all of my pairs, I check to see which of them add to B. So I'm adding all of these together to figure out which ones add to -6. Hopefully you realize here -3 and -3 add to -6. So I replace that middle term. The 9y squared won't change, and neither will the +1. But that middle term will now become a plus a -3y plus a -3y. Oops. And I just rewrote my middle term, -3 and -3. Now there's 4 terms. 4 terms you always factor by grouping. So group the first 2, group the last 2, and find the greatest common factor. So let's see here. The first 2, 9 is 1 times 3 times 3. And then there's 2 y's. And then -3y, I have -1, oops, times 3 times y. And then when you look at these two, hopefully you identify the greatest common factor as 3 and a y. So really you have 3y as your GCF. What's left over? 1 times 3 times y, which is 3y, and then a -1. All right, so we go to the second 2 terms. I have -3y plus 1. Again, if you can see the GCF to that, feel free just to write it out. But I have -1 times 3 times y, and then 1, which is 1 times 1. So we run into an issue here. We don't have a greatest common factor. We don't even have a 1 because we have a -1 and a 1 here. But what I am able to do is I am able to change this -1 to a +1, but make the 3 into a negative, which now gives me the greatest common factor of 1. So I know, I guess I'll just add it on to this one here. I have a +1 times what's left over, -3y plus 1. Ooh, we run into the issue. I don't have a GCF now. Nothing inside the parentheses, or the stuff inside the parentheses isn't exactly the same. Remember, it has to be exactly the same. So how do I make it look the same? Notice it's the same numbers, just opposite signs. So I divide. Let me change this back to a pen. Divide the whole part by -1. So my first polynomial, the 3y and the 3y minus 1 won't change. Remember, you're dividing each part by -1. So now I have a -1, a +3y, and a -1, which makes this stuff in the parentheses exactly the same, which makes it possible to pull out the greatest factor of 3y minus 1. So what's left over once you pull out the 3 minus 1? 3y minus 1. You have 3y in the first part and a -1 in the second part. There's my factored form. But please realize this is not your answer to the factoring problem. This is just part of your answer. Remember, we pulled out a GCF originally. So let's see here. That was just for the stuff in parentheses, but you need to account for that 2y in front. So my factored form of 18y cubed minus 12y squared plus 2y is, let me highlight it here so that way we know it's the right answer, 2y times the quantity 3y minus 1 times the quantity 3y minus 1. I will point out another way that is acceptable to write this is 2y times the quantity 3y minus 1 squared, since there are two 3y minus 1s. Again, either of these are acceptable, just depends upon which notation you prefer. Again, you're able to check your answer by multiplying the problem out to check, but I'll guarantee you that we did this one right.